We are going to go through section 2 today, section 3 tomorrow, and our quiz will be on Tuesday. For the fourth time, 171. Okay. Concurrent, that's a fun word, right? Concurrent. So if we have 3 or more lays, not chips, I'm hungry. Rays, lines, or segments intersecting, we call them concurrent. There's that cute little picture right there.
Which like a triangle?
They have to intersect.
Like that up there.
Like that up there.
Draw a star. Draw it like with like when you draw it like this. No, draw it
Still
like
no.
Why not? There's 3 right there.
No, there's 2.
No, there's not.
2 lines intersecting, 2 lines intersecting.
Not here. There's 1
Okay.
there.
Now, the point of concurrency is Dr. Carson would be happy to host the detentions after school since I will not be here because I have a game. So you think really hard about whether you want to talk to your friends because your detention will be in the front office with Dr. Carson. He went to get his water. 171. Okay, the point of concurrency is the point at which this is occurring. Okay, so if we have 3 lines or 2 or more lines, rays, segments intersecting, then our point of concurrency would be the point in which they're all intersecting. Okay, so today and tomorrow we are going to talk about special points of concurrency. Okay, there are 4 different ones that we are going to talk about, 2 today and 2 tomorrow. Okay, some interesting stuff, I tell you what. We are going to start with the circumcenter. The circumcenter is the point of concurrency of the perpendicular bisectors. So we have perpendicular bisectors that go from a vertex. No, not from the vertex, excuse me. Perpendicular bisectors is the line that goes through the midpoint at each side at a 90-degree angle. So if we draw all 3 of them, the circumcenter is where these 3 intersect. So I'm going to have you draw your attention to this picture right here. Okay. So point P is our circumcenter. Okay. Angle D is our perpendicular bisector. Well, what does that mean? Okay. This is a 90-degree angle and it splits this into 2. Okay. Now let's think back to our notes from Tuesday. Okay.
Great question.
Answer.
Doesn't that also mean that BP and AP are the same?
Read my mind. Okay. From our notes, Tuesday, Yes, it means that BP and AP are congruent. Okay. PE is a perpendicular bisector. Show it. If this guy's a perpendicular bisector, what does it mean?
That BP and CP.
Amazing. If this is a perpendicular bisector, then it means these two are the same. Okay, and PF is a perpendicular bisector, which means we already know it because we have it marked. AP and CP are the same. Okay, so from this picture, what can we conclude? Look at what I have in P. Just look at what I have in P. BP, CP, and AP are all congruent. Okay. The circumcenter is equidistant from the vertices. Okay, that's what this theorem is. Well, that's what we have marked. Okay, our circumcenter is equidistant from the vertices. So PB, PC, and PA all have the same distance. They are equidistant. Okay, when we have perpendicular bisectors, they intersect at a point. We call it the circumcenter. And that point has the same distance to all of our vertex points. Yes, sir.
Is there multiple lines going to that point though? There's like 6.
Yes, but the ones that connect to the vertex are the ones that are the same. Technically, there's, yeah. So basically, it's like 3 triangles that share the 3 sides. Do you see what I'm saying?
Yeah.
Like we have this triangle, this triangle, this triangle. Okay. So here's what we're gonna do. I have some examples that we're gonna do, and when we're done, we'll glue them in, but we're not gluing yet. No glue yet. Okay. Okay, I want to make sure that we're ready for our homework, so here are some examples that we're gonna do together, okay?
Yeah,
Kind of do.
That gaslight, that's like, I mean, that highlighter.
All right. So this is what I want you to do. I have given you this. And it says that W is the circumcenter. Okay, so let's go ahead and highlight the 3 segments that we know are congruent because we have a circumcenter. So the circumcenter, that point W, is equidistant to our vertices. Okay, so what's one of the segments that connects the circumcenter to a vertex? RW is 1. QW and SW. Those 3 are the same. And Zach said they're all what? They're all 24. So right here, where it asks for WS, we can put that that is 24. Now it's asking for RS. Okay, so I'm going to zoom in. RS is this segment right here. Okay, well, if we know that this is a circumcenter, then we know that this is a perpendicular bisector. So what's true about the measure of US?
Oh, yeah.
Okay, so we know it's 19. Okay, so Tyler, what is RS?
RS is equal to RD.
Okay,
So it's 30.
no. No, look up here, look up here. This piece is 19. And since we have a perpendicular bisector, US is also 19. So what's RS?
I'll take that.
They are not congruent. So let's look at RQ. Because in number 2, I'm asking you to find TQ. This piece I have highlighted in pink. If we have a circumcenter, that means this is a perpendicular bisector. And so Carson, what is TQ? Great. Why? Did you ask that? Oh, okay. Are you okay with why it is 16? Do you have questions?
No,
Okay,
never mind. We're not there yet.
we are not there yet. Okay, now we have QV. QV, I have highlighted in green. Okay, if we are working with the circumcenter, then this is a perpendicular bisector. Layla, what's QV? QV is 21. Now, those of you who are looking ahead might be panicking a little bit. Because TW is one of the measurements I'm asking you to find. Which is this right here. Okay, well, what do we know about TQ? We decided TQ is 16, right? And we know that this is a perpendicular bisector. So we know that in this right triangle, the hypotenuse is 24. We know one leg is 16. How the heck could we find the other leg?
A squared plus B squared. So that's the hypotenuse.
Okay, so leg squared plus leg squared equals hypotenuse squared. A squared plus B squared equals C squared. Here's where your calculator is going to come in handy. What is 16 squared? Yes, it is. 24 squared. How do you use this calculator? So if you would just be quiet, I'm going to show you. Quiet. So 16 squared. This button right here is the square button. 16 squared. Square.
What about the special stuff that's like?
Just hold on. Can you do 16 squared? Okay. So now what is 576 minus 256? Okay. If I want to figure out what X is, what? I'm sick and tired of talking over you. Last week I lost my voice. Just stop. Harper, what do we need to do to both sides?
You need to
Okay, what do we call that?
divide it.
Square root it. Okay, so everybody eyes up here. I'm showing you where the square root button is. It's the same button as the square, but it's like in a different color right here. You have to press second and then that button and you'll get the square root.
17.
I got
error.
17.
It's like
error. 8, 9.
Error.
So clear it out.
Wait, what?
Second, this button,
What does second mean?
literally that button right there.
Yeah.
It's just like so that we don't have more buttons. Like every button has two functions.
What does second do?
It needs the second So then we use the second function of that button.
Sorry, press square root. That's what I was doing.
You need to press square root and then to 320. 320, enter. Oh. Okay, so let's try this one over here. For the next one? For the square root of 320? Because you put 2 square roots, so second square root.
No.
WB is this cute little measure right here. This guy right here. So we know that this side is 21 and we know that the hypotenuse is 24. So to set this up using the Pythagorean theorem, x squared plus 21 squared equals 24 squared. Okay, well, we know that 24 squared is 576. 21 squared is
400.
and when we subtract 576, okay, please take the square root of 135.
Oh, sorry, yeah, I wanted to say 5. I didn't see the 6.
With your calculator. Oh, good gracious. Second, this button. No, it's not.
I got 11.135.
Yeah, yeah. What am I giving? What?
Make it a full number.
I question myself.
Okay. Now, do you know why I like you to know how to work these calculators?
So you can use them.
Well, you're gonna have to use them next year. Just be quiet. You can see what you're putting in. You can see if you messed something up, okay? In those calculators, you can't see what you just put in. But when you press enter, you can still see what you typed in. And if you typed it in wrong, you can see that you typed it in wrong.
Oh, actually.
Oh, actually. Okay, now, before we go to the other side, I want to talk about the in-center. The in-center is the point of concurrency with, what do you think? What was the other segment we worked with on Tuesday?
It's like the angle.
The angle bisectors. You do it at the end because I just kind of don't trust you right now.
Just that. Just. Do your homework.
That didn't do anything.
I forgot what you said something about that.
Okay, there should be no noise right now.
Thank you. This was just it. It was
There's a pop quiz.
There's a pop quiz. Yeah. You probably.
Stop. I specifically said, no, Carson.
I didn't even say anything after that.
Yeah, it was.
What I'm gonna have you do is just tuck it in like this And then we're gonna turn the page and talk about the in-center on page 172. So just tuck it in and then let's go to the in-center. Okay. Okay, so let's remember what happens. What? Are you sure? What? You mean? You don't. This is the second one.
Oh.
What just happened?
You didn't even see the water.
Okay. There's some paper towels up there.
Bro,
Okay.
they do really just think that's the funniest thing
Just,
ever.
let's just
Oh
ignore.
my gosh, bro.
Okay. This is an angle bisector because this is our in-center. What do we know that happens with our angle bisectors? What happens to these segments over here? They are congruent. Okay. Ben, do you need to go out in the hallway for a little bit? Do you need it? They're literally right in front of your face.
Oh, I was looking at that.
Okay. If this is an angle bisect, go out in the hallway. Now. Until you can come in here and not laugh. If this is an angle bisector, what is true about these pieces right here? They're congruent. Hey. So when we have the in-center is equidistant from the sides of the triangle. So these cute little sides right here that are perpendicular are all the same length. The in-center is equidistant from the sides of our triangle. And since the in-center is using angle bisectors, we know about all of these relationships with these angles. Okay. So look at your second strip of paper that I gave you. Did everybody get one? Because I have an extra. Paper is actually fine. Okay. So we know that this is the in-center, which means those are all angle bisectors. Additionally, we know that the in-center is equidistant from the sides of the triangle. Okay. Distance is always measured with perpendicular segments, which is why those are perpendicular. All right. So MJP. MJP. This right here. Bryce, what is that angle? No. This is an angle bisector. It's cutting the angle into two equal parts. It is 39. Okay. JKL. JKL. This whole angle up here. Well, what is this missing piece right here? This is 28. So if I know that three angles of a triangle add up to 180, this angle is 54, this angle is 78, what's left over for this third angle? What is 180 minus 40? I thought it was 46. Okay, you realize that these two are both 39.
Yeah.
And these two are gonna be both 28.
Yeah.
So this whole angle is 56.
I get it now.
This whole angle is 78.
Oh, we're trying to look at the bigger picture.
Big picture, yes. Okay,
Where do we get?
that's why. That's why. 56.
It's 40.
Okay. So then NKP. NKP would be what? 23, because we know it's gonna be half of that. KLJ. KLJ. Everybody, what is KLJ?
Today is not my day.
It is not. Yeah, 56. Hey, it's okay. Let's just, Ben's having a rough day. It's fine. Riley. Yes. Okay, NP. Okay, Ben's fine. Jonah, what's NP? Yes, all three that I highlighted in orange are 13. What about KM? KM, which is this guy right here, is gonna be 30. Oh, what?
30.
If we need to find KP, which is this guy right here, what are we gonna have to use? Pythagorean theorem, but this time we are missing the hypotenuse. So it's 30 squared. This guy is 13. This guy is 30, and we're looking for the hypotenuse. So this time we're gonna have 30 squared plus 13 squared, which is gonna be 1,000. 30 squared is 900, 13 squared is 169.
32 is 39.
Oh, good.